Lesson 1, Types of Bonds. What is a bond? Basically, a bond is an intermolecular force that holds one atom to another in a compound. Bond is basically a region that forms when electrons from different atoms interact with each other. And there is energy stored inside a bond, and we call this potential energy. You may recall talking about chemical potential energy, endothermic and exothermic reactions in physical science. So why do atoms bond? Atoms bond together to get 8 valence electrons to become stable. They all want to have that stable octet. Hydrogen is an exception of that because he can only have 2 electrons. So when forming bonds, either you can have energy that is released, known as an exothermic reaction, and these will tend to occur spontaneously, and they tend to form very stable bonds. What happens is we can have a breaking of bonds, and when this happens, energy is absorbed, and that would be an endothermic reaction. The stability will decrease, and an example would be ripping 2 atoms apart, and this will require energy. Think of 2 hydrogen atoms. To rip those apart takes a lot of energy. So which statement best describes the type of energy change as bonds are formed or broken in this type of reaction? Well, if we're going to break apart a hydrogen diatomic molecule and a chlorine diatomic molecule to form 2 hydrochloric acid molecules, the best answer for this would be A. The forming of the HCl bond does release energy. You have to put in energy to break the H bonds and the Cl bonds. There are 3 types of bonds. We're going to talk about ionic bonds, covalent bonds, and metallic bonds. The ionic bonds, these will form between metals and nonmetals. They transfer electrons from a metal to the nonmetal to form a bond. And the reason why is they want to get a full valence shell. They each want to have 8 in their outermost electron. So here, if we look at our electronegativities, you'll notice that sodium likes to give an electron over to chlorine, and this can also be seen here where if chlorine wants to have a perfect 8 and sodium gives its 1 electron, chlorine now has 8 and sodium is left with 8 in its outer shell. The thing to look at is the electronegativities. So elements in an ionic bond tend to have electronegativity difference greater than 1.7. And if I were to look at sodium and chlorine, sodium has electronegativity of 0.9 and chlorine is 3.2. The difference between these two is 2.3. So the electronegativity difference is 2.3. Therefore, it will form an ionic bond. Covalent bonds occur between nonmetals and metals. Nonmetals and another nonmetal. Here they share electrons to form the perfect valence shell. They do this to become stable. The big trick to remember is that sharing is caring and C is for covalent. So why do they share instead of transfer? Well, each element is not strong enough, or the electronegativity difference isn't high enough to remove or steal an electron from another. The elements in a covalent bond have a difference of electronegativity less than 1.7. So if we were to look at carbon and oxygen's electronegativity, you'll notice that the difference is only 0.8, which is less than 1.7, so it will be a covalent bond. Here's an example, and what happens is, this is for hydrogen. Each hydrogen atom has 1 valence electron, but if they come together and share their electrons, now they both have the stable outer s orbital, and they have the configuration of helium. So when it comes to covalent bonds, we do need to keep in mind polar versus nonpolar. And nonpolar has an equal sharing of electrons. This will have an electronegativity difference of 0 to 0.4. They're usually between identical items such as chlorine. Here's an example. And we'll continue with the polar covalent bonds with the next slide.